Hello everyone, this is Vikram and welcome to my channel. In this video, we'll see how to write end-to-end pipelines using GitLab. We'll see how to integrate various DevOps tools such as Maven, Nexus Repository, SonarQube. We'll understand how to build our application using Maven build tool and then scan the source code using SonarQube. We'll see how to generate the artifacts in Maven and how to store them in Nexus Repository. We'll also understand how to containerize our applications and push the containerized images to DockerHub. And finally, we'll see how to use Helm to deploy our application onto the Kubernetes platform running on DigitalOcean. So there are certain prerequisites that we need to have. We need to have kubectl client and Helm installed on our local machine. We already did a couple of videos on how to install these tools. I'll leave the link in the description below. We also need to have DigitalOcean free tier account and GitLab account. We covered these videos in the GitLab as well as the DigitalOcean series. And as an optional, we need to have VS Code editor. But of course, if you have any text editors of your own, you can use them. That includes Notepad++ or any other similar editor. And if you want to understand these end-to-end pipelines much better, you can refer to our Jenkins end-to-end pipeline video. In fact, we had taken those pipelines and we have modified them according to the GitLab CI platform. So you'll see some similarities between Jenkins and GitLab end-to-end pipelines. And whatever concepts that we are going to cover in this series are already covered in our GitLab series. So you will see the repetition of topics, and of course I'm not going to spend more time on concepts. So if you want to understand all these concepts in a much better way, kindly refer to our GitLab series. And you need to watch all the videos in that series to fully comprehend this video. Otherwise, you will still be able to understand and follow this video, but I highly advise you refer the video series in order to better understand the CI/CD pipeline. So these are the various things that we are going to cover, and the primary objective of this video is to integrate various tools. So we may not fully optimize the CI/CD pipeline because those optimizations comes through practice, and you can also optimize it. But integration takes, you will run into multiple issues when you're trying to integrate multiple tools with GitLab. So I'm going to cover all those integrations so that you can work on the optimization part. So these are the things that I'm going to teach you. So I'm going to talk about CI platform of GitLab and also help you understand GitLab jobs, stages, types of variables supported, what are artifacts, services, and executors. So some concepts are very similar to Jenkins, but here they have a different meaning and they have different use cases. And installing Kubectl Helm we already covered in one of the videos, including creation of DigitalOcean account. And I'll also help you set up various tools such as GitLab Runner, Nexus Repository, and SonarQube. So initial part of the video covers how to complete this whole CI/CD platform using the shared runners provided by GitLab. But towards the end, we'll also see how to create our own GitLab runner on the same DigitalOcean Kubernetes platform and run our jobs inside Kubernetes pods. I'll also help you understand how to use Kubernetes load balancers and PVCs on DigitalOcean cloud. So of course, these are also similar to other cloud platforms. And we'll see how to run our jobs inside Kubernetes pods, use Maven as the build tool, and how to push the artifacts that is generated out of the build process to Nexus Repository. We'll also see how to scan our source code with SonarQube, creation of custom quality gates for the application, how to containerize the application and push the images to DockerHub. Finally, we'll end the session with deploying our application onto Kubernetes using Helm charts. So let's understand the CI/CD pipeline first. So this pipeline looks very similar to the Jenkins end-to-end video which we had seen, but here we have removed some parts which are not compatible with basically GitLab. So here as a first step, we are going to see how to push our source code to GitLab. And once GitLab gets the source code, so it starts the CI process where it builds the source code in the first step using Maven as a build tool. And after that, we'll run the SonarQube stage where it will scan the source code and send it to the Sonar server. In the Sonar server will analyze the quality gate information, and it sends the information back to the your CI/CD, that is GitLab CI/CD. Now if the quality gate is passed, so your pipeline continues to go further, otherwise your pipeline will be stopped and the rest of the stages in the pipeline will be simply skipped. So if everything is done, if quality gate information that comes from the server is passed, we'll go to the next stage, that is the artifact which we created. So we can store that artifact in SonarQube in hosted Maven repositories, and at the same time we'll also containerize our application and then store our image in the DockerHub. And finally, once this is done, we are going to deploy our application to the DigitalOcean Kubernetes platform. So we already covered how to generate the Helm charts for the application in the Jenkins video, but still we are going to see in a bit, in this video. So this is the complete CI/CD pipeline that we are going to follow. But before implementing the CI/CD platform, so you need to make sure that you have Kubectl and Helm installed, and GitLab account and DigitalOcean accounts. And whenever we work with Nexus and SonarQube, at that moment you can install these tools in the Kubernetes platform. So let's understand what is the pipeline. So basically CI/CD pipeline will comprise of series of steps that will be executed in an order to complete the release of your software. So there are mainly 3 different stages involved in a complete CI/CD pipeline. Those are build, test, and deploy. Even GitLab uses these names as a standard. So if any job doesn't belong to, if any job belongs to these stages, so those jobs will be executed in this order. That is, any job belonging to the build stage will be executed first, followed by the test and deploy. And where do we write this pipeline? So basically GitLab will read this file called .gitlab-ci.yml. So our complete GitLab CI/CD pipeline should be in this file at the root of the project. So every time when you update this file, so basically GitLab will read this file and run all the stages and jobs that are defined in this file. So we need to have this file at the root of the repository. And GitLab offers some free minutes every month in order to try their shared executors. So we have 400 free minutes of CI/CD we can use to probably test and learn GitLab CI/CD. And there are other premium plans as well. So as you go to the higher plans, you'll get more CI/CD minutes. And this is a sample GitLab CI/CD pipeline. So if you see at the first stage, you have the stages, and the stages are by default, these are 3 standard stages, that is build, test, and deploy. So of course you can also write your own stage names, but these are the standard ones. And since stages is taking the list, so basically these will be executed in the order. So first build stage will be executed, followed by test and deploy. And if you see, these are all the jobs here. So all these are individual jobs, and every job must belong to a stage. So here if you see this build job belonging to the build stage, and if you don't mention any stage name here, so it by default belongs to the test stage. And you have script here. Script here are the similar to steps in the Jenkins pipelines, where this script block will have all the commands that should be executed for that particular job. Similarly, we have the test job that is echoing some information, and there is also another job. So this is also executing something. So this is a basic CI/CD pipeline where we have stages and the individual jobs that belong to a stage. Now let's understand much better about these stages and jobs. So every pipeline will comprise of stages and jobs, and a collection of jobs becomes a stage. So build stage can have multiple jobs belonging to that stage. And here every stage will be executed one after the other, but all the jobs that belong to a stage are executed in parallel. So that's the default arrangement in GitLab CI/CD. And stages are dependent on the other stages sometimes. And here, as I said, every job belongs to one of the stage. So if any job is not marked to any stage, so it by default gets assigned to this test stage. And if any job fails, the pipeline aborts. Again, this is the default behavior, but of course you can control it with other parameters, that is allow failure to true. So in that case, even if some of the job fails, your pipeline will still continue. So that's that's an extra configuration. Let's understand about the variables here. So variables are very important in case of your pipelines. So these are also called environment variables, and these are these can be used per stage or per job level also, so depending upon where you exactly mention your environment variables in the pipeline. So these are similar to environment variables in Jenkins also, and they control the behavior of jobs and your complete pipelines. So there are multiple areas where you can define these variables. So you have predefined CI/CD variables. So these are like by default environment variables. So these also comes with Jenkins also, like job underscore name, job underscore URL, build underscore URL. So these are the default variables for Jenkins. Similarly, you have for GitLab. So there are certain predefined CI/CD variables, and you can also define your variables inside your pipeline in the GitLab-ci.yml file. Also, you can set it at the project level variables, and in fact we used some project level variables in this video, which we are going to see. And there are group level variables. So these variables will be inherited by all the projects inside that group or the organization. And also when you're triggering the pipelines through an API call, at that time also you can send some variables through API. So if you want to learn more about the variables, do check out the link that is given in this presentation. So this is how you define variables in case of Jenkins. So if you have seen it, so we have variables defined at the pipeline. So these are all the global variables. So these will be inherited by all the stages, or else you can also define stage level environment variables. So those are restricted to that particular stage. So let's understand how the variable should be defined. So variables saved in this gitlab.yml file should store only non-sensitive information, because this GitLab CI file will be checked into the source code repositories like basically your GitHub or GitLab. So this should not have any sensitive information in the form of the variables like the database, passwords, etc. They should have only non-confidential data like URLs, usernames, that doesn't have any basically sensitive information. And in case of any sensitive variables, you can go for project level variables, where project level variables can only be defined and modified by the maintainer role, the person who has the maintainer role. So these are much secure. And GitLab also has some use list of predefined variables similar to Jenkins. So you can find all the predefined variables by just running a job with printenv as the command. So this will basically print all the predefined variables and their corresponding values that are relevant to this particular pipeline, because every pipeline will have different job name or different probably URL or anything like that. So these environment variables are dynamic in nature, so do check out their values when the pipeline actually runs. And here as I said, these are dynamic and you can use it, and you can call them inside your pipelines by simply calling them with a dollar followed by the variable name. So these are the predefined variables. So we'll also see some of them in our actual pipelines. So if you see here, the CS server name, it is set to GitLab, and then say job name. So currently which job is running and triggered this printenv command. So that also you can see the username and the pipeline source. So how you trigger this pipeline, whether it is a push event or a merge request event or through an API. So even that a value can be fetched using this environment variable. You can see the pipeline ID, present working directory, the home, so the default branch, and also you have the job URL similar to Jenkins. So these are all the predefined environment variables, and these are dynamic in nature. And of course you can also set the variables at the global level. So these are the predefined variables, but you can define your own variables. So the variables that are defined at the root, so these becomes the global variables. So I have defined this variable name to be global underscore var, but you can also put it as x:10. And all the variables, let's say if they are very special in nature, always try to make sure that you put them in the capital so that it will be easier to understand whether it is a special variable or a normal variable. And these variables will be by default inherited by all the stages. So of course you can restrict this behavior by putting variables empty parenthesis. So this will block inheriting the global variables. And if you see here, there is this job, and inside this job I also have some variables defined. So these are basically variables that only their scope is restricted only to this job. That means you can access these variables within this job. If you see here, so I have this local variable which I can print using echo $, the name, And also, since this global variable will be inherited, I can also access global underscore variable. But if I try to access this variable here in this job, so it will simply fail because that variable will not be existing or propagated to the other jobs. And also sometimes you need to store the variables in the form of files, just like your PEM files or Kubernetes kubeconfig files. So anything, you can also store them as a file and use that file using again dollar the name using which you stored that variable. So if you see here, we are just setting a cluster in the kubeconfig file using the file information stored in the variables. And sometimes you might need to mask variables, because once you set a variable, you can easily see it by echoing it. So in case if you want to protect a variable from not getting displayed in the job logs, so what you can do is you can mask it. So masking is only applicable for the variable set through project. That is through if you're setting some project level variables, there will get an option to mask that variable. So masking will simply will not allow any job to display that variable value inside the job logs. But still, if you want some more way of accessing and storing your values variables, you can always use external secret providers like Vault by HashiCorp in order to better manage your secrets. And let's say you have a lot of jobs defined and you are in the testing phase and you want some of the jobs not to get executed. So in this case, you can do one thing. You can simply comment out a job so that it won't run whenever you run the pipeline. Or else what you can do is at the you can rename the job to include dot at the beginning. So this will just hide the job. These are like hidden files in Linux. So similarly, you can also put dot at the beginning of job name, so to hide it or disable it. So if you put a dot, this job won't be executed in your CI/CD pipelines. And here by default all the jobs will be executed one after the other. I mean, if they belong to a same stage, they'll execute parallelly. But if they belong to different stages, of course every job will run one after the other. And these are all automatic. Let's say you wanted to trigger a job manually through user input. So what you can do is you can use when conditions to set it as manual. In this case, your pipeline will wait until you manually trigger this job. So since this is the deployment job, so that is at the last, so this one will wait for the user input, and whenever user clicks on run button on the GitLab UI, so this job will execute. And not only this, you can also have other values to this when. So by default it is on success. So when I set this to on success, so which means if the jobs the earlier jobs, once these are succeeded, then only this destroy job will run. Because as I said, if any job fails in the CI/CD pipeline, the other jobs will be skipped. And also you can set it to manual to trigger this job manually. You can also set it to always. So if you set it to always, in this case what happens is, irrespective of the status of the other jobs, whether they are passed or failed, this tester job will continue to execute. And on failure, so this will run only when one of the jobs in your CI/CD pipeline fails. And never don't run this job. So you can skip a job either by putting dot, this will completely hide. Otherwise, when you can set it to never, so this job will never run. Now let's understand the keywords. So keywords are also very important. So there are a lot of keywords and we covered most of them in our GitLab series. So let's understand one of the important keyword, which is called image. So every job inside your in your CI/CD pipeline runs inside a Docker container. So this is much better because instead of we provisioning an environment that is required to run a job, we can run it in the pre-existing Docker image. So that will anyways provide the necessary execution environment. So by default your pipeline will run inside a Docker container that is based out of Ruby 2.5. So that is the default image, but this Ruby 2.5 will not have all the dependencies required for all these stages. So in this case, what we'll do is we'll use different container images for different jobs, or for collection of jobs. So these are similar to using Docker containers as build agents in Jenkins. So we can also use Docker containers, but this is the default nature in GitLab. So if you see here, I have the default image that is set to Maven 3.8, which means all the jobs will now use this image Maven 3.8.2 if they don't have any job level images set. So let's assume I don't have this at all. In this case, this build job, it is not defining any job level image tag, which means it will by default use this. Similarly, this test job, if you see, I also have the image that is set to Python 3.7. So in this case, this particular job will run in this container because you are replacing the default image with the job level image keyword. So this is how the images will work here. And coming to the before script and after script, so every job has to run something. So here I can put whatever I need to execute under the script, but let's assume before running the script I have to run some more scripts or some more configurations. So what I can do is I can create before underscore script, and I can simply run some commands depending upon the use case. So this before underscore script will execute before the actual script. So of course I can also use them like this. So I have the script here. So the script will run this particular echo command, but before that, whatever you put under before script will run. And here this before script also you can put it to defaults. In case if the jobs doesn't define this before script, the default one, which is defined at the global level, will be inherited by all the jobs. But in case of desk job, it is also defining one before script, so the global one will be replaced with this local one. And similar to before script, we have the after script. So after script will run after your actual script. So depending upon the requirement, again, let's say that in your script you try to open a database connection or something like this, then after the script you can close the DB connection by putting those commands in the after script. Of course you can also put it in the script block, but you also have this after script block, so that you can have like these defaults. So if all these stages are using some sort of before or after script, you can put them at the default level, so every job will basically inherit them. And we also said that any failure in a job will not let the other jobs to run, but this behavior can be controlled by using allow failure. So if I put allow failure to true, so what I'm saying here is that this job 2 is allowed to be failed, which means the other jobs will still continue to run irrespective of the status of job 2. The default value is false. That's the reason why if any job fails, we'll see that the other jobs are skipped. Now let's talk about the other types of keywords as well, like rules here. So rules are like conditions, so that can either include or exclude jobs in your pipelines. So these are like conditions only. So rules are evaluated in the fashion, but before understanding rules, let's see some example first. So here I have a job by the name job itself, and I have some commands that are defined in the script. So I have rules here. So what this rule says is, so there are two if conditions. So as I said, rules are evaluated in the order. So if the first condition fails, it will look for the second condition. If the second condition also fails, this job will not be executed. So here so there are some predefined variables that first we are going to understand before this rules keyword. So here one of the important predefined variable is CI underscore pipeline source. So this will define how your pipeline is triggered. So whether the pipeline got triggered through a merge request event, or someone pushed some changes into your source code, or someone created a schedule, or this triggered through an API call. So this CI pipeline source will define that value. And we also have CI commit ref name. So this is the branch or the tag name for which project is built. Let's say your project is building for the master branch, or whenever a tag is created. So this commit ref name will be either the branch name or the tag name. And you also have one more predefined variable which is called ci commit ref slug. So what is this ci commit ref slug is, it is exactly equal to ci commit ref name, but there are some modifications that will be done to this name. So let's say this ref name has a lot of special characters or some capital letters, underscores, or whatever it is. So what happens to that particular name is it will be converted in this fashion. So what is going to happen is any capital letters that are defined in this name will be converted into lowercase letters, and the complete length of the string is shortened to only 63 bytes. And not only that, like 0 to 9, A to Z is replaced, anything other than the numbers and smaller case letters are replaced with hyphen. So let's assume I have this name called like this. So here what happens is all the capital letters are shortened, and also the length will be shortened to 63 bytes. Anything apart from 0 to 9 and small a to z is replaced with hyphen. In this case, exclamation and hash will be replaced with the hyphens. And any leading trail, let's say after converting your complete ref name into 63 bytes, and the 63rd byte, if it is an hyphen, so it will be completely removed. And so basically we use it for naming the Docker images tags. So let's say I have this as the reference name, probably the branch name or the tag name. Then this will be converted into, so dots will be replaced with hyphen again, because all special characters will be replaced, and again plus also will be replaced with hyphen. Any capital letters will be converted into lowercase. And coming to this rules, so here what will happen is, so first your job will execute only when it is a merge request. Only when the pipeline source is a merge request, then only your job will execute. So if the first condition fails, it will go to the next. So this will also run when you have a scheduled job. In that case, this pipeline will execute. And also here if you see, so not only there is one condition, there are multiple conditions in the first rule. So first rule says that if it is a merge request, and also we are setting it to manual job. So when I set it to manual job, which means so someone has to come and trigger it. So if someone if no one clicks on that start button, that is start the job button, so this will continue to wait and it will block the rest of the pipeline. So in this case, if you want to skip this particular job, that is without blocking the rest of the jobs, you can put it to allow failure equal to true. In this case, what will happen is, even though when the job is set as manual and it is waiting for the user input, so it will not wait, your control will go to the next job. So next job will continue to execute without getting blocked. So in case if you want to come and execute this job, log into the UI and simply press the start button, so it will continue to start. So if you don't have this allow failure equal to true, you're basically, if this rule is satisfied, you are completely blocking the rest of the pipeline. And also you have rules such as changes here. So let's say your pipeline source is a push event, so this job has to run. So even though if it is a push event, so this particular job, which is basically containerizing your application, should only run when there are changes in the Docker file. So not only push event, so I'll only run this particular job in the pipeline when there are changes to this Docker file. So if there are no changes to this Docker file, I will not run this job even though it is a push event. So that's the advantage of changes. And here I've simply used changes test.log. So which means if there is a change to this log file, then this particular job will run. And sometimes I also need to run a particular job when a certain file exists. Let's say this Docker build job, which is containerizing your application, run only when there is a Docker file. So if there is no Docker file, your Docker build command will definitely fail. So here the rule says if Docker file is existing, then only you run this particular job inside the pipeline. Now let's understand the services a bit. Let's assume that you have created a pipeline and then you have containerized your application. Now you wanted to test that application, like you have created a Python application, and then you have to test it by saying whether it is able to connect to a database or not. So my requirement is creating a database. My requirement is to have my application connect to a database. But where exactly is this database? So this database already existing, or do you have to create it just for testing your application? So let's see what will happen, what we will do. So let's assume we are installing MySQL in one of the Docker executor. So this is an extra process, right? So in order to test your application, you are yourself creating one more container, and then you are installing MySQL. Or let's assume you run MySQL Docker container and let Python connect to it. This is also not possible because your pipelines are running in GitLab, and if I have to test it with MySQL, I have to run my MySQL container somewhere and let my Python application connect it. So anyways I can do it, but this is again a complete waste of my time. So do I have any extra other alternative where GitLab itself will create such containers just for my testing activities? Yes, it is possible through services. So services, what will services do is services will create another container depending upon the requirement and let you talk to that container within the CI/CD pipeline itself. So if you see here, I have a test job and I defined a MySQL service. So this MySQL service is basically a container. So this service will run a container with MySQL as the image, and I'm also naming that particular container as MySQL. And since we know that MySQL container needs some default root password and the database to be supplied as an environment variable, like whenever we create MySQL container, we just use docker run and we supply environment variables like this, right? MySQL root password and -e, some other thing to be used as environment variables for that container. So here this service is perfectly creating a container. And if you see, I have this main.py file which basically starts my Python application and connects to a database. Since I already have the the host of database set as MySQL internally in my Python code, so it will look for MySQL a host. Here I created a container and I set alias to be MySQL. So this Python application will connect to this service, which is basically the container which my GitLab created for me, and then this job will be successful. So at the end of this job, even both your test job container that is created and also the service container will completely gets destroyed. So this is how you service. Then the possible reason why we would be using services is, let's say I have an requirement of Dockerizing an application. So of course I will use Docker file, and I'll also use a Docker client. But where exactly is my Docker daemon running? So Docker daemon has to be available in order for me to build the application. So here my every job runs inside a Docker container. But inside a Docker container, again, if I have to build a Docker image, I will not have any Docker daemon. So will I install daemon in the container and do it? So it is not again possible. So I'll be should I use Docker in Docker? Again, that's a very complex process. So should I go for any other alternative methods of building my container image? Yes, of course you have Kaniko also, but here using services I can also do. Since services, what I'll do is I'll start the Docker daemon, and as the actual image for this job, I'll use Docker client image. So this Docker client can talk to the Docker daemon and perfectly build my application. So this is again another use case with services. Now let's talk about artifacts. So before understanding artifacts, let's see how where exactly these artifacts are actually stored. So we know that every job inside your GitLab CI/CD pipeline runs inside a separate environment, that is Ruby 2.5 container. So within this container, so basically a workspace will be created. So this workspace will be in the form of builds, your Docker GitHub username, group, and the project name. So under this directory, which will be available in this container, anything that you do within your job will be saved. Let's say you are creating some files, so it will be stored in this directory. So this directory will be automatically created within each container that is assigned for a job, and this location you can call it as you can access through some predefined variables, that is CI project directory. So GitLab stores under this directory. So let's say that your job requires you to clone some repository. So your clone repository will be in this directory within this container. So let's see what will happen if I try to use that workspace. So here I have one of the job that belongs to the build stage. Here I am simply running a Python file and redirecting to build.log. So this build.log will be under the CI project directory, which is under builds username and so whatever location that we had seen. So this will be the location. So now I have another job. So that is just trying to cat that build out log which is generated in the other job. So here if you try to cat that log from the same location, probably in the same CI project direct location, you'll get an error and this job will fail. The reason why is every job here runs in a separate container. So whatever data that is generated in this container will not be shared to the other container, because all the containers are isolated and every job gets a unique environment each time. So how do I share that artifact or share that file so that the other jobs can use them? So what will be the use case? Basically, let's say I have a Docker file that containerizes my application, and as an input in one of the command, I just used war file, copied the war file into the container image in one of the Docker file step. So where do I get this war file? So I'm getting this war file from the build stage where I generated this demo.war file. So this demo.war file has to be containerized in a separate job, which means this demo.war file should be there in the other job as well. Okay, so how do I actually share the data across the jobs? So I can share it using artifacts. So using artifacts, I can share a complete path or a set of files to the rest of the jobs. So artifacts once set in one of the job will be automatically inherited by all the jobs, so without actually or explicitly asking for the artifacts. So if I say artifacts and the path build.log, so here I'm generating build.log in some location, and that path I'm setting it as an artifact, and I'm also setting the artifacts to expire in 1 week. So in this case, what happens is this artifact, this build.log file, will be available for all the jobs after this job, exactly with the same name, which is build.log file. Now in this case, if I try to cat on this build.log file, so this will generate this will show the build.log file which is generated in the previous job. And also you can also control when to generate the artifacts and all that, so you can refer the official links. So this is how artifacts really work. So an artifact generated in the any job will be stored in the server. So this particular job will upload the artifacts into the GitLab server, and GitLab server it will automatically inject the same artifact into the rest of the jobs. So the rest of the jobs have access to that artifact. And also not only that thing, so the artifacts which are generated by one of the job, so you have an option to download that artifact. Let's say I have generated a war file, or I generated some build.log file. So once I artifact it, so it will be available for me to be downloaded as an attachment from the GitLab UI. So basically that artifact will be available in the form of zip format. Now let's understand about runners and executors. So by default, as we said, every job inside my CI pipeline will run inside a Ruby 2.5 container. So how do I control that behavior? How do I use my Kubernetes pods as build agents, or how do I use my Linux bare metal as the build agents? So all this comes under the runners. So basically runner is an application, so that will work with GitLab CI/CD to run your jobs. So this is similar to an agent is Jenkins, and it is completely written in Go language. And you can also run your the runner in your local machine, or in your VMs, or as a container, or as a Kubernetes pod. And this runner has to be basically registered with the server. Let's say that I have my GitLab instance running in somewhere, and I have a Kubernetes cluster which I'm going to use as the build agents. Like I'm going to create pods in that Kubernetes cluster, and these pods will act like a build agents. But how do I actually connect my Kubernetes cluster with the Jenkins instance, so that to the GitLab instance, so that GitLab can create the pods in that Kubernetes cluster? So first what we are going to do is, first we are going to run a runner in the Kubernetes environment. So that runner, once it is up, it is going to connect back to the GitLab server, so that GitLab server can use that runner, and that runner can create pods that will act like the job environment. So this is how you act how runners will work. First you need to install the runner and have it connected back to the server, so that server can talk to that runner. So this is what exactly we are going to see in our video as well. And once you have the Kubernetes environment, and if you want to use pods as the build agents, so what you need to do is, first you need to connect, or first you need to run a runner in the Kubernetes environment. So basically that runner is again a pod running in the Kubernetes cluster, and that pod will connect back to my GitLab server. So how do I connect is basically when I go to the GitLab runner section in the UI. So GitLab will give me a registration token and the URL. All I have to do is I have to provide these two information to the runner, so the runner can connect back to the GitLab. And once the runner is connected back to the GitLab server, so you're going to see the status and also modify by adding tags to the runner and also remove the runner from the GitLab UI. So again, we are going to talk about all these, how to connect and all in the actual demo. Let's understand Docker in let's understand everything again. So that's it. So let's go to the practical section and understand. So that's it regarding the theoretical part. Now let's understand the project that we are going to build and how to set up various tools and get started with our pipeline. So this is the Spring Pet Clinic project that we have selected to work with the complete CI/CD pipeline. And before understanding this, let me also show you the official Spring Pet Clinic project. So I've already cloned this official Spring Pet Clinic, forked it, and then I just made some modifications like adding the Helm chart for this application, and also I have kept some Jenkins files and updated the readme, also put my Docker compose file. So this is what I have used even for my Jenkins end-to-end video. So if you look at the Jenkins end-to-end pipeline, so I've also used the same example, and here also I have set up SonarQube, Nexus, and a lot of things I've covered in this. So I'm going to take this pipeline as the reference. So we're going to replicate the exact step, but with respect to GitLab CI environment. So if you see, I also have the manifest files, pet clinic, Helm chart, etc. So basically what I did is I cloned that pet clinic project here, and I've also included some Helm charts for pet clinic project, and also Helm chart for SonarQube and Nexus Repository. So of course you can also download the latest charts and modify them according to the environment, but I've placed exactly the chart versions which I have used to set up Nexus and SonarQube. And here I also have the deployment.yml file on how to deploy the application, the Spring Pet Clinic application, by using a LoadBalancer as the service type. And for reference, I also kept the Jenkins file that I have used earlier. So we're going to take the reference of this Jenkins file and see what all steps that we have used in Jenkins, and we are going to use them for GitLab also. And also I've created a separate readme.md file, so that will have all the information necessary to build the GitLab pipelines. Anyways, I'm going to upload the final GitLab CI/CD pipeline file, but if you are interested in starting from scratch, you can use the small code snippet from here, so that will help you better. So I have the POM file changes that I need to do, so I've kept those sources here, and also what what changes goes into Maven settings.xml file also I've kept it here. And the Sonar project properties file also is available here, how to build the container and how to use the runner and how to register it, how to tag a runner, how to use Kaniko to build container images. Basically we'll be containerizing in two different ways. So one will basically start the Docker daemon as a service, and also once we migrate to our own GitLab runner, we'll see how to use Kaniko to build container images, and also how to install SonarQube, Nexus are also given here. Some a Docker file. So this is the Docker file which I have used to Dockerize this application, and also this is the Docker file which I have used to build a custom image with both Kubectl and Helm binaries. These are the deployment and the service files for deploying Pet Clinic project and some of the important resources. So I've already given everything here. So I advise you not to directly take the GitLab pipeline. Instead, write everything from scratch by taking the references from this readme.md file. So now let's see how to just create a repository in our GitLab and push the source code over here. source code into that repository and see how to start with our GitLab CI pipeline. Now let's go to GitLab project creations page. So I hope you already have GitLab account created. So what I'm going to do now is I'm going to click on this new project. Also, you can also click on this plus sign and click on new project. So we are going to create a new project where we are going to put all our source files. So let's click on create a blank project. So I'm just selecting my username since I already have one more group. So this one I'm going to just call it as GitLab some Spring Pet Clinic. It is up to you. So whatever name you can use. And this one I'm setting it to public for now. And initialize a readme file I don't want. Just click on create project. And so I hope you already have set up your Git CLI. So I'm not going to talk about this. So what I'm going to do is I'm going to go back to my this folder. Just open up a terminal and then first initialize this as the Git repository by doing git init. And so after this, so I can add all these to the staging area by just doing git add -a. And then if you see the status of the Git repository, so I can see there are a lot of files added. So now what I'm going to do is I'm going to just commit them by using init as the commit message. So I committed all of these. Now just check the git status in case if you are left out something. So it is not there are no new files. If you just check the git remote -v, so as you see there are no remotes added. So let's create a remote. So git remote add. So by I already added my SSH key, so it will be easier for me to push also. So all I'm going to do is I'm going to take this particular link and just add it as a remote by using git remote add. I call this remote as origin. So I'm going the git URL, so add it. Then I can just use git push origin master to push all my changes. So in case if you have not set up any SSH keys, so do check out, so do set one so that your push will not ask for any password. So this is a basic step, so we don't want to spend some time again teaching this. So let's refresh this particular repository and you see all the files. And here if you see there is no gitlab .gitlab-ca.yml file to start the pipeline immediately, and this is the readme file. You can always refer and create the pipelines. So let's do one thing. Now let's start creating the pipelines. So just click on this new file and name this file as .gitlab-ci.yml. So this is the GitLab CI/CD file. You can also see that the icon has changed to indicate it is an CI/CD file. So the first thing that we are going to see is we are going to actually write the series of stages. I'm going to first write the build stage because I'm going to build my source code first. And before that, you can also write some check stage and to see whether certain prerequisites are already available or not. So I'm just going to delete this build stage, and as the first stage what I'm going to do is I'm going to since this is a Maven project, because there is this pom.xml file, so I'm going to just check whether this Maven is installed in the Ruby 2.5 container or not. As I already said, of every job runs in a container which is based out of Ruby 2.5 image. So first we need to check whether Maven is existing in this particular Ruby container. So the name of the job is check version, and this belong to a stage known as check, which we already defined. And then so as a script, so sorry, this is not a list element. So first we need to create a script, and then the script will run a series of steps. The first step is I would like to check for the Maven version whether Maven is installed or not. So let's save this file, then use git add I'm adding and committing at the same time by using git commit am. And So this is the untracked file. So first we need to add it for the first time. So git add dot gitlab -ci.yml file, and then use git commit init. It's up to you to give a proper message, but since so this is a demo, I'm just using init as the commit message, and then git push horizon master. So as soon as you push changes to your GitLab with the CI file, so what you are going to observe is you are going to go to the CI/CD and click on this pipelines part. So automatically a pipeline will be triggered. So whenever you have this ci.yml file, GitLab will automatically start the pipeline, and individual jobs of this pipeline can be viewed by using this job, and it says it is failed immediately. So let's go to the set of jobs that this pipeline has created. So if you see, you have a job known as check-version, which is obvious from this name, and the status of this job is currently in the failed state. Okay, let's see why it failed by clicking on this failed button. As you see, the job run in Ruby 2.5 container, and then so it says Maven command is not found in this container, so that's fine. And look at the other look at the rest of the build log. So only Maven command is not found, and that's the reason why it failed. So let's go back. Now what we are going to do now is we are going to use a custom image for my check version job. So for this I can set the image to be used at the job level, but since I have majority of my jobs running Maven, so what if I set a default image? So I'll put a default. So default image, I'm going to set it to Maven. So for this I can just go to DockerHub and find the relevant Docker Maven version, Maven containerized image. So let's search for Maven. So I'm interested in Maven 3.8 based out of Java 11. So I can search for 3.8 in this filter tags. So 3.8. So I can look for OpenJDK 11. Because my job requires Java 11. So I'll be using 3.8 basically 2, so this will give me better results. So 3.8.2 OpenJDK 11. So I'm going to use hyphen adopt OpenJDK. So this OpenJDK, so which means I need to search for hyphen OpenJDK. So I'm going to use the 11 version. So this one I'm going to use 3.8.2. So let's take this image name and simply put it here. So now any job that that doesn't define any image will automatically run in this. So now let's commit this particular code and see whether this will pass my job or not. So let's push the code. So as soon as you push the code, so your pipeline will trigger. So I'm directly going into the jobs. I don't want to see the pipeline again. Now let's see this running job. So this is now creating this Maven 3.82 container, so that my the whole pipeline, I mean this whole job will run in this particular container based out of that image. So this is the first step, that is to check whether this Maven is responding properly or not. Well, after that I will not run this job, because running a job means it is going to take a lot of time, because it has to create a container, so it will take a lot of time. So if you see here, I have Java 11 internally installed and it is based out of Maven 3.8. So this is completely okay for me. So now what is my next step is to actually build my Maven project. That is I need to build the source code, and then I have to actually use SonarQube to scan it. So for this I'm going to create one more stage called build-job. So this is just a naming convention, and I want this to actually belong to a stage known as build, and I need to mention the build name here as well. And since this check job will take a lot of time, and I know that Maven is already installed, so I'm going to put dot, so that this one will not execute again. And one more thing here, so even this build job will inherit this Maven image and run this job inside the Maven container. So stage is already set. Now as a script block, so I need to run Maven package. So this will compile the source code and also pack it in the form of distribution in the form of jar or war file. Now if you see the pom.xml file, so the packaging format is war file and the version is it is set as 1.22. It is up to you to set any name, let's say 1.0, and the artifact ID is Spring Pet Clinic and this is the group ID, so that is completely fine. So now mvn package will create a war file, and so what I can also do is I can also simply print something like this, building the war file, something like this, just to see it in the log, and then mvn package, and the next step in order to see whether that is generated or not. So I'm going to do ls. So I know that this war file will be created under the war file target folder with some name. So I'm just going to put star.war file so that I'll be able to see that war file is generated or not. So this is a very basic build step. So I'm going to just commit this code again and then push it to the repository. Now let's see by going into the jobs. So here, if I have not disabled this job, you would have seen two jobs that are triggered one after the other. So here this is directly going to the build job. This is not executing the check version job because we have disabled it. Now let's click on run. Let's see the build output. Since this is a very big project, it is going to take at least 5 to 10 minutes of time. So I'm going to skip this build part. So once the actual build has started, so let's wait till it starts. So it has started and it will take some time. So I'm going to just skip this video and go to the last statement of this build log. Now you can see that this war file is generated with build marked as success. You can also see where exactly this war file is generated. So it is under this CI project directory under target. This war file is generated with version 1.0, and our ls-l target.war file is also generated. So this is the first step, that is generating the war file. So in the next step, what we are going to do is we need to actually scan this sonar stage. So for this we need to have a SonarQube up and running. So in my case, I already have the SonarQube set up, and I'll leave the link in the description below on how to install and bring up the sonar scanner. Sonar installed in your DigitalOcean. So if I just show the Kubectl get pods, this is already showing the cluster. So I have my SonarQube up and running, and also if I get these services, you can see that SonarQube is available in this service, that is this one, 10.245. Sorry, this is the external IP, this is the load balancer IP. So I'm going to just copy this URL, and this is running on 9000 port. So let's go to the UI first. So I already covered this installation steps and how to change the default password and all. So I'm just trying to log in into this particular Sonar scanner instance. So I think I did not change the password, so let's change this password as well. So now my SonarQube server is also up and running. So what I need to do first, so in order to understand how to use SonarQube and all, so first we need to understand what it does. Basically it will scan your source code, and for scanning the source code we also need to create a project inside it, and after scanning, your Sonar scanner CLI will basically send the results back to the Sonar server. So for this we need to have the project created in the SonarQube server, and also have the client scan the source code. So there are two steps. One setting is the setting up the project, and now the second step is having the Sonar scanner client to scan your source code. First, let's set up the project part. So what I'm going to do is I'm going to click on this manual and use the name called Spring Pet Clinic. So it is up to you, so which name you use. And this is the project key basically, and this is the project display. Now click on setup. So with Jenkins, with GitHub, with GitLab CI, so I can just click on the GitLab CI for now and click on Maven. So it is giving me some kind of suggestions, but I don't want to follow it. Let's go back. Let's click on locally. So it is saying generate a token first, so to push the analysis. So let's create a token which is valid for 30 days maybe, and click on generate. So this is the token that we need to copy somewhere. So let's copy into our probably maybe I'll just put it in the GitLab CI -file by commenting it out so that I won't lose it. So this token will be used later, so I just saved it somewhere. And then you can click on continue, click on Maven. So it is saying you to actually run the Sonar analysis on the source code using this Sonar plugin, but we don't have Sonar plugin. So there are actually multiple ways Sonar client comes actually. So the one is through direct installation of Sonar scanner client, that is directly downloading the binary file, or else you can have the Sonar client available as a Maven plugin. The third thing is you can also use Sonar scanner as the Docker image and have your source code scanned with that image. So there are actually multiple ways. So this example here, it is saying to use Sonar scanner plugin, but we'll use a different method. That is, we'll take a Sonar scanner Docker image and have our source code executed within that image. So for this we need to have some configuration needed. So let's actually click on this hyperlink to see if any information is given. Sonar scanner for Maven. So as you see here, they are using this Maven Sonar, which is basically a Maven plugin, but we can also use it in a different way. So I'll talk about that. So here our project is created with this token. So for now the server part is completed. Now let's go to the pipeline part. Here what I'm going to do is I'm going to actually create a stage known as probably Sonar scan, and here this belong to a stage called you can also use your own stage naming convention. So here I'm using a stage name called Sonar scan, and also you need to set the order of stages execution. So in my case I have set it here, and now I need to run this inside the CI/CD pipeline as the Docker container. So for this I need to understand how to actually use this Sonar scan in the GitLab pipelines. So for this I think I already gave the link. So what you have to do is you have to just go to this link and see how to use Sonar scan in GitLab CI/CD. So let's go to this link. These links are already given. So Sonar scanner builds Sonar scanner running GitLab CI/CD jobs can automatically detect. So this is information, you can actually go through it. So let's understand some of the important things that you need to consider here. In order to complete your analysis, you need to do a couple of things. One, setting some environment variables, that is Sonar token and the URL. So these are the two different things that are needed in order for the analysis to be complete. And the other thing is we need to do some configurations in the CI file. So let's see how to actually execute the Maven project. So here they have clearly given way to run this Sonar scan stage. If you see, they already gave the image name, not here. So SonarQube check image, yeah, this one. So this one basically is for Maven. So if you are trying to use the Maven Sonar plugin, then this is what you will use. Otherwise, if you want to execute Sonar scan within the container image, So this is the container image which is already provided by the provided in the SonarQube documentation. So here we are going to exactly use the same thing. So let's use the name which is dedicatedly for this particular stage. So let's go to our CI stage. Let's use this image. So this image will be now used, and this stage belong to the Sonar scan. Now coming to the script block, because we need to run the analysis. So for this we need to write that script. Let's understand how to write the script. Maybe they'll also give the same. So what they are saying is you can, within the script, you can invoke the Sonar scanner. So basically this is the binary available within this Docker image, and then they're asking you to wait for the quality gate. That is, only when the quality gate information is received to the Sonar Sonar scanner, then only this job will be marked as success. Otherwise it is going to be marked as a failure. So this is what we need to do inside this script. Let's execute it. And so there are other changes also to be considered. So let's use this script. So this will scan, but the problem here is what to scan, where exactly is your source code. So all these things also you need to actually understand. So before that, let's also have some variables. So if you see here, they are also asking us to set these variables to define the location of the analysis. So let's do this also. So these are all stage level variables. So here under the project directory, so under .sonar directory, so SonarQube is going to put all these analysis results. So this is completely fine, but in the requirement also SonarQube is asking us to put sonar underscore token and host URL also. Let's put both of these. So in the same environment variables, so let's put the sonar host URL. So sonar host URL, if you go to the SonarQube which is actually running, so till 9000 is our URL. So let's just copy this here. So remove the trailing slash, so this is not needed. And one more thing they are asking us to input is this sonar token. So let's copy this token as well and then put it here, and as a value to the token, so just copy whatever you just copied it here. So let's take it from here and then put it here. So far this is fine. So we have configured the environment variables, use the relevant Docker image, and then invoking sonar scanner binary with some environment variable. So here this D indicates an environment variable which says wait for the quality gate, but there are still something that you need to provide. So if you go to this documentation or somewhere, they'll also ask you to put the sonar properties file. So that one you can get it when you read about the sonar scan and all. So but what I did is I already have a sample project.properties file which is given here. So basically whenever sonar scan has to scan your project and send the results back to the server, so it needs certain information like where are the source files, where are the test source files, where are your Java binary files, where are the class files. So what we need to do is we need to actually give these configurations. So there are two ways of giving this configuration. Let's assume I wanted to input or tell to sonar scanner this is the location of my test directory. Then what I can do is within the CI file I can give that as an environment variable like this. So here I'm setting sonar test folder to be src test, because so under the src folder, under the tests only, I have all the test cases. But instead of giving them in the command line, what I can do is I can create one more file at the root of the directory. So that file I'll call it as sonar-project.properties. So without this file, so SonarQube will not get any configurations. So this is sonar-project.properties. So that value I've already given it here, so we can just give the same information. So project key, project name. So if you go to your project creation page, So this is the project name, which is spring-pet clinic. So the same will be your key and name as well. So this is the version, sources, binaries. So if you see clearly, so SonarQube is also scanning your .class files. SonarQube will also scan your src and main. So this target directory also should be accessible by SonarQube. Okay, so this is a requirement that you need to remember. So now this is the only configuration needed for your scan to work, but there is only one issue here, so that you're going to understand once you run it. So here in the project properties, we are talking about the target folder, but in this particular pipeline, your target folder will be available in the build job, but it won't be available to the Sonar scan, because the Sonar scan, so every job will actually clone this particular repository into each and every job. So once build job clones that repository and builds, then it will have the target file. But in case of Sonar scan, it will just clone this repository, but it won't build it, because there is no mvn package command in the Sonar scan, which means it will not have the target file. So as we already discussed in our theoretical session, so we said that using basically the artifacts, you can share some files and folders. So what I'm going to do now is I'm going to go to the GitLab documentation and then search for GitLab artifacts and see how to give the artifacts. So this is how you give the artifacts. So artifact, whatever is the path, and then expiring. So I'm just going to use the same thing, and we need to put it at the build job. So build job will generate these artifacts, and the path of the artifact is the target folder. If I have to share only the var file, that is star.var file, as an artifact, then I have to give the only the var file. But the Sonar scan stage doesn't require only this var file, because I'm looking at the target folder. Under the target folder, again I'm looking at the classes folder, which means this complete target folder has to be shared across the Sonar scan stage, and of course to the rest of the jobs also it will be shared, unless I turn it off. So this target folder has to be actually sent to the Sonar scan stage also. So this is how actually this target folder will be shared, and your scan will be success. So let's do one thing again. Let's commit this particular code and then push it to the master. So now we have two jobs, so build job and then Sonar scan, both belong to a different stages altogether. Now if you click on jobs, so first your build job will run. Again, as we know, this build job will take a lot of time. So after that your Sonar scan stage will run. So let's wait till then. Now if you see, our var file is generated, and you can also see one more step. It is uploading the artifact, that is, it is uploading the target folder, so that this target folder will be available for the rest of the consecutive jobs. And now this job is successful. Now let's click on the jobs again. So this should have triggered the Sonar scan stage. Let's click on it. So again, this will also scan all the source code and publish the results to the Sonar server. So where did we give the Sonar server details? So this is where we have given. So first is the host URL and also the token. And if you see where exactly this will push the result to which project, so that project name is given in this project key and project name under the sonar-project.properties file. So it will authenticate using these credentials and push the result to the particular project using this key and name. So it says there is an error, and it says you must define mandatory properties, unknown property, project.key. So there is an unknown property, project.key. So where is this project dot so unknown property projects.key file, sonar-project. Let's go to the repository. Sonar-project dot spring pet clinic. Oh, so we did a small mistake here. So if you see, we did not actually commit this untracked file. So let's commit it, git add -a, then just commit this, and then let's push the changes again. So again, this will actually start other jobs as well. If you see, again it will start the build job. So it is again will take time. Let's wait. Now the war file is generated and this target folder is being uploaded as an artifact. So this should start the next job in some time. So let's click on the jobs, and if you see, Sonar scan stage has started, and it is executing this image Sonar scanner CLI. So it says waiting for analysis report to be processed, checking the quality gate, which means it has pushed the results to the server and it is waiting for the quality gate. So at this moment I can simply refresh this page in the SonarQube server, or else go to the list of projects, and if you see, it is configuring the analysis, or maybe let's click on this. So you can see here it generated some results, but if you go to the pipeline status, it is still waiting for the analysis results. So it says quality gate is passed. You can view the results here by clicking on this, which will directly point to the basically SonarQube. Let's go back and see in the server part. So quality gate is passed, as you see here. So there are 42 bugs and code coverage is 94.1. That is there are 39 unit test cases, 0 code duplications. So this is the quality gate information which we clearly explained in SonarQube sessions. But if you see, we can also create some custom quality gates, and we can also see how the pipeline fails if the quality gate is not met. So this we are going to actually skip for now. So if you want to understand how to create custom quality gate and fail the pipelines, so you can refer to our SonarQube basically series. And next what we are going to do now is so we're going to do one thing. Since SonarQube scan is passed, we will now save our war file which is generated in the build stage in the Nexus repository. If you see our the total pods running, so you must have also seen the Nexus already set up. So I'll leave a link in the description below, so you can also make Nexus up and running on DigitalOcean. And Nexus is running on this public IP on port 8081. So let's see Nexus also. Let's log into Nexus. Now what our main intention is, to store the war file in Nexus repository. Let's also take the reference from Jenkins end-to-end pipeline. So if you see, so there is a different method that we followed in case of SonarQube. So in SonarQube, the properties file is not provided directly. Instead, the properties are injected in the form of environment variable. So that is the difference. And also wait for quality gate, it is done differently in case of Jenkins. And in Nexus stage, if you see, I have just used some Nexus plugin and all, which is based for Jenkins, but we don't have any Nexus plugin. And also Nexus can push the artifacts to the Nexus repository. I mean, we can push the Nexus artifacts to Nexus repository via using the API calls through curl. So this is another method, but we will not use this method. We'll see how to use differently. So for this, let's log in into our Nexus by clicking on sign in. So already we have set up a different password, I think. So I think I did not set up a different password. Let's see how to set up. So the default password is available in this location, that is Nexus data.admin password, but this is inside the Nexus pod. Let's first exec into Nexus pod and then find that password, which is the default one. So in case if you already changed it, you don't have to do it again. So I'm just invoking the bash process inside this pod, and then do cat. So where is this Nexus password? It is here. Just copy this particular password. So it is still this bash. So let's paste it here, and let's complete this wizard. So new password also I'm setting it up. Disable anonymous access, we don't want it. So first thing we have to do is we have to create a repository to store all the war files. So for this I'll go to the settings tab, click on repositories, and then create a repository. Okay, and then what we'll do is we'll create a Maven hosted repository. So if you want to understand what is this Maven hosted and all that stuff, you can actually refer to our Maven series. So this Maven hosted can host both release and snapshot dependencies. Okay, so first what I'm going to do is I'm going to just name it as Maven hosted. You can also use your own name. So this version will only support release, snapshot, or mixed. So it is up to you. So if you have snapshot dependencies, you will use snapshot. If it is release. Otherwise, if you want to store the combination of both, use mixed. Okay, so this is release repository. And then what I'm going to do is I'm going to disable redeploy. So disable redeploy in the sense, so if I already have a artifact with 1.0 as the name, version name, so I cannot store that same artifact even if I try to push it again. So this is true for release repositories, because you should not actually override the artifacts which are already stored. But if it is any snapshot dependency, or if it is a test repository, so you can give an option to the users to override the artifact versions. So for now I'm just disabling redeploy, so that my pipeline will fail if it tries to push the same artifact again. So this is how I do it. Just click on create repository. And also one more thing, so in order to authenticate with this Nexus repository, you should create a token and use that token instead of passwords. So this concepts also we have clearly covered in our Nexus series. So for now we are just going to use the username and password, but in the real time you should not use the direct password. You have to authenticate with your user tokens, which are also known as personal access tokens. So we have set the repository, but the main question is how do I actually push my artifacts. So if you have seen my Jenkins end-to-end pipeline, I've used Nexus plugin to push it, but I can also use Maven basically MV and deploy phase to basically push my artifacts. So for this I need to make a lot of changes in my pom.xml file, and also I need to have my setting.xml file in place. So let's also do that. So for this I'm going to name this stage as push to Nexus, and then this stage belongs to so you can mark this stage as some push or anything like this. So I'm just going to name this as push, and here I need to also have the script and other stuff, right? So I'm going to use script. So this script will actually use MV and deploy. So MV and deploy basically will deploy the artifact which will be generated on the target folder into the Nexus repository or whatever repository that you have used. So this MV and deploy needs access to that war file, so which we are already providing it to all the jobs in the form of artifacts. So these artifacts will also copy the war file. So this MV and deploy will have access to the target folder in this particular job also. But the main question in place is what are the various changes that we need to do. So the first thing that we need to do is we need to make pom.xml file changes. So if you go to Maven pom reference, so you'll have various options regarding this pom file. So one such option is the distribution management. So if you have already seen this readme.md file, so I've given this distribution management here under the repository section. So if you go to the official repository and check for the distribution management, you will understand that distribution management it manages the distribution of artifacts, like where exactly you want to push your artifacts. it can be your release artifacts or snapshot artifacts, it can be anything. So this is the distribution management. This is how it looks like. Basically if you go through this readme file, so here I have this repository which is for release repository, and the similar one for snapshot repository. But in our case we have just created the release repository. So if you already if you want to store the snapshots, you should also create this snapshot repository, but it is up to your choice. And also here you can just give some name and the URL. So this will be the URL to your hosted repository. So I'm just going to copy this distribution management and I need to paste it under the repositories. So let's find out where repositories are available. It can be anything, so it can be under the dependencies also, so it is up to you. So but I'm just putting it here. So distribution management, and here I'm calling this as Nexus. So there is a meaning for this ID which I'm using as Nexus. So let's understand that later, but here first let's here snapshot repository is also created. So let's also do one thing, let's create this snapshot repository also. If you remember, so we have created this Maven -hosted. So this is the one which is storing the releases. So let's do one thing, let's delete this repository and let's create from scratch for both. So I'm already in the settings page, just create this repository Maven hosted. So this one I'm calling it as MVN hosted release, that is rel. So this is the release dependency it will store, and releases I am disabling the redeploy. Okay, that's it. Okay, so just click on OK. Sorry, create repository, and the next repository I'm going to again create Maven to hosted, and here Maven hosted snap for snapshot, and this will only store the snapshot. For this I'll enable redeploy, that is allow redeploy. Click on create. So I need to use both these names. Okay, so here this is the host URL. If you see, basically this is a variable I'm using, so that variable I can replace it in the properties section. So just copy this particular name, and here in the properties, so this will serve as the variable for me, so that in case in future if the URL changes so I can basically change it here instead of finding out all the occurrences and changing it there. So just open and close these like this, and then also you have to just close it. Inside it I can just paste the Nexus URL. So till 8081 is your Nexus URL. So just paste it without any trailing slash. So I think I also given it in the basically in the readme file. Okay, so pom is using this variable, and that variable has to be replaced in this location. And in the distribution management, so this is the name, so I can name this as Maven release repository, and similarly this is Maven snapshot repository. And so here if you remember, we just gave the name called MVN hosted rel for release, and here MVN hosted snap for snapshots. Save this file. And one more thing here we need to understand, so this is the URL, but how do you authenticate it? So authentication should details should be placed where? So that is the main question. So here if you see the authentication ID I'm using as Nexus, so this ID should have basically username and password to authenticate to the Nexus. But where do I put? So basically I need to put them under the server section of the Maven settings.xml file. So if you go to Maven reference, or if you click on this Maven home page and look for settings.reference, you can click on this use button, use option, and click on settings reference. So somewhere you'll find this server information. So here server information will have some ID, and then username password I can put it here, so that this will actually this ID will actually hold the username and password, or maybe username and token. And this ID can be used in the pom.xml file like this. So pom.xml file will basically take that ID, username and password, and it will authenticate for pushing the artifacts. But where do I put that settings.xml file? Basically settings.xml file will exist in two different locations. So one is your home directory under the .m2 folder. So that is one location. So let me write it also. So this, once you have the Maven installed, so under the home directory you will have this settings.xml file here, or else settings.xml file can also be available in your installation directory. So under the installation directory there will be again a conf folder. Under the conf folder there will be a settings.xml file. So once you install Maven in your local machine, so this settings.xml file which is existing in the setup directory is global, but the user level it will be in the user's home directory under .m2 folder. But I don't have either of these folders because I don't have Maven installed. Basically Maven is not installed, and Maven image is available. So this is the default image I have, and push to Nexus basically is also using the same image because Maven is installed in this image. But I cannot have m2 and the settings.xml file uploaded to that image, because that image will be fresh every time. So what I have to do, so I can give other location of that settings.xml file by giving -s as the command line and the location of that settings.xml file with respect to a repository. So in this way also settings.xml file can be actually given to the Maven client tool. So in this case what I'm going to do is I'm going to basically within this repository at the root I'm going to create a folder known as .m2. So okay, so it got a file has been created. Let's do one thing, let's create a folder under this m2. Here inside this I'm going to create a file known as settings.xml. So in the settings.xml file I'm going to actually put the complete information. So same thing I can copy. So I can copy this settings.xml file template, just remove these extra 3 dots here. So under the server section I'm going to mention the ID as Nexus, because this Nexus ID is the same ID I'm using in the pom.xml file. Okay, so here Nexus, let me delete the extra stuff. So as the username of Nexus I can give the username and password, but username and password again if you give it here it will be again a problem, because this file is there in the repository and I cannot expose these credentials. But what I can do is I can provide them as an environment variable, so Maven can read that from the environment variable. So in this case I should use $, so within the parentheses I should use environment variable, and whatever environment variable or the variable that you wanted to inject into the project, so those variables will be automatically injected into your particular jobs of your pipeline. So this one I'm just calling it as Nexus_user, and for the other one I'm going to put as Nexus_password. So in this case my data is completely safe, because so I'm not giving anything in the repository, so everything will be available inside my project settings. So this is how I can in fact give my settings.xml file that is in the repository, and also I can put my I can use a custom location for this settings.xml file. I mean Maven can find that settings.xml file from a custom location, that is. So now it is -s, which is a short for settings that you can provide to Maven client, and .m2, inside .m2 I can give my name which is settings.xml file. So this way I am still providing the settings.xml file, and also in the settings.xml file I'm not exposing any particular information. So this maven deploy command will deploy the artifact. So one thing here, so let's also we also need to consider one more thing here. Instead of putting this m2 here, what I'm going to do is I'm going to put as environment variables, or you can also put it as variables, so to show you how the global variables work. And in the global, since these are some extra configurations, so I'm just using m2 some extra. You can use options or anything like this, and then within the quotes let put this settings.xml file and use this as an variable. So this way in future, if I have to provide any different extra command line flags or the settings that I have to give, so I can basically add them here in this particular string. So this is completely fine. So now my Maven can read these extra options, that is settings file, and settings.exe file is expecting the environment variables. But where do I put these environment variables or the variables? So should I put it at the job level in the form of variables and then give the Nexus user and Nexus password? Again, that is a security concern from me, because these variables will be visible. So in this case, what I'm going to do is I'm going to go to project settings, that is the Spring Pet Clinic project, and then I'm going to go to the settings and then CI/CD. So this is where I'm going to add some variables. So let's go to the variables part here, then click on add variable. So here whatever variables that I am interested in, I can use. So the keys I'm just using as Nexus underscore user, and the variable value, so admin is the variable value. So I don't want to protect it, because protect a variable will run on protected branches. And also masking is not needed because it's an user name, so anyone can see it. Just click on add variable. Let's click on another variable and create another call Nexus underscore password, and here this value I'm going to put it as the password value. So this is a plain text actually. So anyways, I'm going to destroy the instances, so it's completely fine. So otherwise you can use the tokens. Protection variable is not needed, but masking is needed. So otherwise, if someone uses $nexus password, the log will show the Nexus password. So I wanted to mask it. So click on add variable. So these are added, and these variables are provided to your complete pipeline, so every job can access it. That's the reason why. So in the settings.xml file, so we try to read Nexus user and password from the variables, because these variables are injected. So let's add so basically let's add all the latest changes and then commit it and then push it to the master. So before that, I wanted to do one more thing in this pipeline. So let me disable this Sonar scan stage, because we already tested this stage, and this push to Nexus doesn't depend on Sonar scan stage. So basically we are just skipping this. So now only build job will run, and then after that it will push your artifacts to Nexus. So of course you can also use some echo statements and other stuff, which is not needed as of now. Since there are some latest changes, let's add and commit again, and let's push them to the origin. So once it is successful, you can again see the job. So the first again is the build job. So this will take some time as usual. So our job is successful. Let's go to the Nexus job. It is in the running state. So it is again based out of this Maven image, because it is simply using the Maven commands. So let's see what will happen once it tries to push to Nexus. Now if you see, it says upload failed. It says could not find artifact. Okay, so there is a typo. So somewhere we made a small mistake. So here, yeah. in the GitLab, I think in the pom.xml file. So it is not Maven, it is just MVN. So this is a small issue. And now what I'm going to do now is I'm also going to disable this build job, because this is also taking some time. And directly what we are going to do is we are just going to push to Nexus, because anyways it is MVN deploy. This is again going to also generate the war file in this particular stage also. Let's simply see this particular stage only. Let's commit all the changes and then just push it to master. So this will just start this push to Nexus stage. Now build is successful, and it is also pushing to Nexus, and Nexus job is also successful. Let's see Nexus by going into this browse artifacts and click on this browse. Go to Maven hosted release. If you see here, we have a Spring Pet Clinic 1.0 artifact. The reason is, if you see this pom.xml file and scroll to the GAV parameters, so we have the artifact ID with this and 1.0 as the version. Now what will happen if I just rebuild the same source code and try to build is this artifact Nexus repository will not allow it, because if you go to settings and see this release repository settings, we have actually disabled redeploy of the artifacts, which means, so next time if you try to push this war file, you definitely have to change this war file version and then send. So in case if you are developing the ongoing snapshot dependencies, all you have to do is you have to use snapshot here. So this is going to use the snapshot dependency and push your snapshot version into the other repository, which is a snap repository which we created. But this repository will take redeployments. That is, if you're trying to push the snapshot dependencies again and again, this repository will accept it. Now this is about pushing to Nexus. So this is again a straightforward. So now what I'm going to do is I'm going to disable this also, since this is also successful, and I'm going to unhide this build job. So this will generate this target.war file. Now what I'm going to do is I'm going to dockerize this particular war file and then push it to DockerHub. So for this I already have the Docker file created, so which is using this OpenJDK 8 image, and then taking the war file and then putting into this user bin into this OpenJDK image. After this, as an entry point, it is just running that war file by serving the by starting the application on port 8080. So for this we need to access this war file. Anyways, I'm going to I'm already using the artifacts, that is the target folder. So any job that needs any job that is created will automatically have artifacts, that is target folder access. So now what I'm going to do is I'm going to again create another job called Dockerize. So for this I'm going to use the basically the stage as Dockerize, and that stage order also I need to mention it. So these are all the not properly ordered stages. If you want, you can also shuffle the stages as well. And the one thing here is for Dockerizing, I need to have the active Docker daemon up and running. Since I cannot actually install a Docker daemon within another container, so I'm going to use the help of services. So as a services, I'm going to start one image, that is Docker Dyn. So Docker Dyn is actually Docker in Docker, in which Docker daemon is available as a container itself. So whenever you're starting this container, so your daemon will also start. And for talking to the daemon, I need a Docker client. So the Docker client is available under this Docker latest image. So this Docker latest image, by default what this will do is it will talk to our TCP socket, that is Docker, I think it is 2375, which we already covered this in our GitLab series. So by default this client will connect to the daemon, and that daemon is already running as a service. So this one will actually this setup will actually have the client and the daemon. So now I can actually run my script, which is basically docker build command. So docker build. So I would like to use some variables here. So my DockerHub username I need to provide, DockerHub password I need to provide, and in order to push it. So for this I need to first authenticate before pushing. So for this only I'm using the before script, and in the before script I'll be using docker login, and as a username I'm going to use the username variable which I'm going to create in some time, and as a password I'm going to just use the password variable like this. So in this step I'm just basically logging into the DockerHub account, and now in the script I'll use docker build, and I'll tag it with my basically username, so followed by the image name. So image name, what I wanted to do is I wanted to set it at the global level so that anyone can change it very easily. So image name, again let's use as Spring Pet Clinic, so no other names, so Spring Pet Clinic or any name is okay. And here we need to tag it with our username slash the image name. So this we already know, so image underscore name. And as a tag, so there are multiple ways of naming these tags, so it is up to you. So if you want to define a tag which is a number, you can also use. But I use basically ci commit SHA. So whenever I make a commit, a SHA will be generated. So I'll use this SHA so that every time my docker image tag will be unique, but SHA will be very huge in size. So if you have any other methods of tagging, so you can follow that process. So here I'm using dot to mention the correct context as well. So after this I also have an habit of tagging this image with the latest one so that I can push both. So I can just, instead of this, I can also use latest. So my image will be tagged with latest also, and then I'm going to actually push both the latest one and the old one, both. So docker push the latest one. So it's pretty straightforward, so needs no further explanation on this, because we already worked on Docker, how to tag, how to build, what is a build context, logging, etc. So for this, before committing, let's do one thing. Let's basically log into my DockerHub account. Since I cannot directly use my DockerHub credentials, I'm going to create a token for myself. So I'm already logged in. Just click on account settings and click on security, access token, create a new access token, token description, let's say GitLab, read write. I just want read write only, no deletion. Just click on generate and copy this token. Now I have to use this token in my GitLab settings. So settings, CI/CD, and go to variables, click on add variable. So username, it's okay, I can expose it because all the images will be tagged with this name. So protect, uncheck it, click on add variable, and again add variable. So you can use password because these are the two names I'm using. So this is the personal access token for Docker, and mask it because I don't want to show it to anyone, just variable. Okay, so I have both username and password added, and since I made the changes in this pipeline, so what we need to do is, so we need to basically commit this and then push it to the master. So again it's the same thing. So first your new war file will be generated in the build job, and after that it will be dockerized. So this is a service that is starting the Docker daemon, and this is the image that is having the Docker client. So we already covered this, so if you want you can refer the GitLab series for better understanding. So let's go to the list of jobs. So as we are very sure that the first job will be build job. So this particular job is successful. Let's go to the Dockerization stage. Even this is also successful. So if you see, Docker build is successful, and it has started this Docker Dyn service, which is a Docker daemon, and then it has executed this particular job in the Docker latest image, which will have the CLI. And then if you see the Dockerization is successful. At the same time, it has tagged with this particular commit SHA, and also it has retagged into the latest, and it has pushed both latest and this particular SHA image. So I can just verify it by going into my DockerHub and then just checking. So if you see here, just a minute ago, so I have some latest changes pushed. So this is how you push your changes to the DockerHub. Now let's as a final step, let's deploy our application into the Kubernetes cluster. So for this, I already have the pet clinic chart created. So basically it's a very simple chart. So if you look at this deployment.yml file, you would easily understand. So what I'm doing here is I'm just creating a deployment with one replica, and then the container image, I'm just using this name which we just pushed, the latest image tag, and this runs on 8080. So here I'm just creating a service type called LoadBalancer for this particular application, so that the load balancer IP will be generated. And the same thing I've already put it as a Helm chart. So if you look at this chart, you would easily understand. So what I'm going to do now is I'm going to create a stage. So for this, I'm temporarily disabling the Dockerize stage because I already have this latest image. I don't want to build it again. At the same time, I'm going to stop this build job because these two are not needed for the deployment to K8 stage. So I'll just say that deploy to Kubernetes, and then I'll just name it as the deploy stage. So for that, I need to actually put deploy here, and then so what I have to deploy. So for this, again, I need to use an image. So image I'm just using as so my own image. So that is the CLI image, which has both kubectl and Helm. So for this, in the readme.md file, I already shown how to create this image, and this image is available with this particular name. So I'm going to put it in the GitLab. So the problem with this image is it won't start anything as a process. It starts, I think, Helm. So if you look at the base image, so it is taking Helm. So what is issue with this is it will expect the Helm command. So by default, it will wait for the arguments to the command CLI, I mean Helm CLI. But since we are not providing anything, so basically it will result in error every time. So this you can just see without before that, let's do one thing. Let's run this script. So in the script, what I'm going to do is I'm going to just use Helm list in order to see what are the Helm releases, but to which Kubernetes cluster this is going to connect. So that is the first thing we need to understand. So I already have the configuration file that I downloaded from the DigitalOcean. So if you go to the DigitalOcean and go to the Kubernetes, so when I created the Kubernetes cluster, so they gave the access to this kubeconfig file. So if you just download this kubeconfig file, so it says replace it, that's fine. So let's open it. So this is the kubeconfig file that I got. So what I can do is I can just take this kubeconfig file and then store it as a file inside the GitLab. So let's go to the settings and go to the CI/CD and click on all variables, expand. So click on add variable. So this one I'm going to use as kubeconfig, and then as a value I'll make the type as file, copy the file contents, unprotect this, you can mask this, so this cannot be masked, so uncheck this and click on add variable. Now so far this is fine. So I actually just created a variable of the type file, but how do I actually give this in my pipeline? So if you see, that's the reason why I also included the kubectl within the same. um, same Docker image. And before actually running this Helm list, so what I need to do is I need to actually see the contents of that kubeconfig file, that is cat, and within the single quotes dollar kube config. So this is the content of the file. So the content of the file, I'm just going to replace this. So where do I need to put this? So basically kubeconfig or Helm will look for a file known as .cube, and inside the .cube it will look for a file known as config, so where your Kubernetes cluster config should be available. But before that, let me also create this directory in case .cube is not available, to be on the safe side. So this .cube is also created, and then I cat the contents of the file and redirect it to this kubeconfig. So here Helm list, so this one will list all the Helm releases. So if you see, I disabled basically all the jobs except for this deploy to Kubernetes to show you so what is the error that I faced and how I actually fixed it. So in the terminal, let's actually commit all the files and then push it to master. And if you look at the CI/CD jobs, so the deploy to Kubernetes will basically launch a new container based of the new container image which I created, that is this Kubectl Helm CLI latest. And if you see, it is saying unknown command sh for Helm. So why it is giving this unknown command sh for Helm? The reason is, so in this image the entry point is basically Helm, and whenever I give any commands in this script, so these are shell scripts, so your command will be like Helm, and to the Helm sh will be given as an input. That's the reason why it is giving all these errors. So for this, what I'm going to do is I'm going to just disable this entry point called Helm. So for this I need to arrange them in this format, so you can refer to the official documentation. So image name is this, but the entry point I'm going to actually mark it to null, so within this square brackets, or else you can also use this notation, array notation. So what I'm going to do is what I did is I just disable the entry point so that it will not have any entry point. Now let's commit these changes and push it, and let's refresh this. Let's go to the jobs. You see that the other job is starting. Again, it has created the container. Now if you see, so there is no error. So kubeconfig file is copied. Helm list, it is saying Nexus and SonarQube. As we already expected, these two are releases that I have used to deploy Nexus and SonarQube. Now what I'm going to do is, since Helm is working, so let's install the Helm chart, that is Helm upgrade -- install. So this command will see whether old release is available or not. If old release is there, it will upgrade it, otherwise it will install. So the release name I'm going to use as pet clinic, and here I have the pet clinic chart with this name, that is pet clinic -chart. So I already checked into the repository, but if you want to use Nexus as the repository, that is Helm chart repository, so do check out my Jenkins video where I clearly explain how to use Nexus as the Helm chart repository, or else you can also refer the Nexus series where we talked exclusively on this part. So here within the Helm chart, it is using latest image, and since I already pushed the latest image, so this deployment should be successful. So let's commit this change again, and let's wait for this particular deployment. So again it is running. So if you see pet clinic releases doesn't exist. Now it has released it, and I think the deployment is successful. Let's manually check it from our local terminal. Just use kubectl get pod and svc. So you'll be able to see that pet clinic service is created of type load balancer. Now load balancer is in provision state and pet clinic container is running, and you can also see Helm list to see the pet clinic release. So here pet clinic release 1, it is revision 1. So the pet clinic service will take some time for the load balancer IP to be available. So before that, let's revisit everything that we have done. So we know that every container basically use Ruby 2.5 as the image, but some of the jobs require Maven, so that's why we set the default image to be Maven. So for the jobs that do not define the image inside their job configuration, will be forced to use this image. Otherwise you can also define your own job image. So these are the variables that we have used to set the settings.xml for Maven and the image name. These are the order of the stages. So first we are checking whether our Maven is installed or not in this particular image. So this is not at all needed, just for showing the syntax that I've used. And build job, which is basically building packing our source code into the var. And then we are using artifact to share the target folder for all the other jobs. And SonarScan, basically we have used the URL and the authentication here. So the rest of the properties are available under Sonar project properties file, and we are using the SonarScan CLI, which is containerized image, to invoke the that particular client. And so to that particular client we have passed this quality gate wait equal to true. Let's say in case if you don't want to wait for the quality gate, you can disable it by putting as false, and then push to Nexus. So we have used Maven deploy command to push, and we have configured everything in pom.xml file, that is the distribution management. And under the settings.xml file we have created we have added the Nexus repository credentials. And in the Dockerization state we have used the services concept, where GitLab will create another container with the image that is mentioned in the services. And as the Docker client image we have used Docker latest. Basically both are same, one has the daemon running, the other has the client, and we have used the combination of both to successfully build and to containerize and push our images to the DockerHub. You can also use your own Artifactory or repository stores to store the images. But here my Nexus repository is running on HTTP, and by default Docker client will not allow you to push to insecure registries unless we do some configurations. But to avoid all that stuff, we have used DockerHub. And finally deploy to Kubernetes, where we have used the custom image built with kubectl and Helm install. And then we just use this Helm upgrade -- install to release the application. Now let's go and see whether the service object is provisioned or not from the kubectl get pods and svc. And if you see pet clinic load balancer IP is provisioned. So let's do one thing, let's quickly visit this URL, and if you see that application is working, so you can explore this application. This is not our intention. So basically we took an application so that has a lot of plugins and other stages, so that our pipeline will be using all those things. So this is how you actually write end-to-end pipelines in GitLab. But here if you see, we are using the shared runners provided by GitLab. So we never used our own runner, that is even though we have the Kubernetes cluster, so we have never used Kubernetes pods as a build agents. So in the next section we'll see how to use Kubernetes pods. So for that we need to install GitLab runner on the Kubernetes, where that GitLab runner will talk to the GitLab server. So far we talked about how to use GitLab shared runners to run our jobs. Now what we are going to do is we are going to set up our own runner inside our Kubernetes platform setup on DigitalOcean, and see how to use Kubernetes pods as build agents for your CI/CD pipelines. So for installing GitLab runner, let's go to official GitLab documentation, and you can click on this install runner. So runner can be installed on bare metal, and also you can install it on Kubernetes as a pod. So there are different ways You can see we can also install on Kubernetes. Just click on install on Kubernetes, and there are certain prerequisites also to be met. That is, you need to have this version of Kubernetes API and kubectl and Helm client installed. So already we have everything set up. So let's do one thing. Let's add this repo and try to actually install GitLab runner in Kubernetes. So for this, I'm just adding it here. So in my case, it is already added. So let's pull it. So Helm pull. And what is the name of the chart? So it is actually GitLab/GitLab runner. Because we need to actually make some changes. So that's the reason why we are pulling it first without actually installing it directly. So now if you see here, we have this runner downloaded. So let's open the values.yaml file of this runner. This is the image that runner is going to use. Image policy if not present. So replicas is one, that is fine. So here we need to add few parameters. So one is this GitLab URL for the runner to get registered. So by default this is giving some random values, and then runner registration token. I'll tell you from where to fetch these values. And other things that we need to do is creation of RBAC. So basically GitLab should be able to create runner should be able to create pods. That's the reason why we need to create RBAC for GitLab runner to work properly. So apart from this, we don't have to do anything. Of course, if you want to add some tags to this, you can also add tags. So let me see from where to add them, or else we can simply search for tags. Here specify the tags associated with the runner. So I'm going to just add one tag here, that is K8s. Let's see if it is actually reflecting once the runner is created. And what we'll do is we'll go to the GitLab instance and see how to register a runner. I think you can go to settings and CI/CD maybe, and in the runners expand this. So basically there are no runners associated yet. So if you see, we are all using the shared runners. So this is the URL that I need to use in the Helm chart when creating the runner. So let's add this URL. Instead of this, just replace the one given by GitLab. And this is the runner registration token. Let's copy it and paste it here. So this is done. Let's save this file and go to the terminal. Now install runner. So using Helm install. So runner, I'm releasing with the runner name, and the chart is GitLab hyphen runner. So we'll also see the RBAC part, what exactly it is deploying. So for this, let's see kubectl get roles and role bindings that it is creating for the runner. So if you see, runner has created a role and role binding. Let's just describe the role and see what permissions this role has. Kubectl describe. So if you see, it has all the resources, access to all the resources and all the verbs. Okay, so it can do anything in this namespace. If you see, this is released in the default namespace, and it has access to everything. Let's see whether runner is successful or successfully running or not by doing kubectl get pod. If you see, runner is already running, so which means I should be able to see it here. Let's refresh this page, and if you go to the runners section again, so if you see here, I have the runner up and running. So this is the runner. Now if you want to add some tags and all, so just click on this edit button. So if you see, I already have the tag K8s, which is added through the Helm chart, and you can also have the maximum timeout set, and you can also run this, use this runner only on protected branches, and the other stuff also you can change. So let's click on save changes. So what we are going to do now is we are going to actually modify this particular file, that is GitLab CI-.yml file, to use that particular runner. So for this I'm just going to take the backup of the original one, and then I'm going to rename it with shared runner, so that it will be easy to identify. And also I'm going to remove this dot. So that is the original one. So this one we will try to use it for our CI/CD using our newly created runners. But here I have no way of mentioning the runner to, no way of saying GitLab to use the currently created runner. So for specifically selecting a runner, we need to again make some modifications. So here if I just go to use GitLab, and or else if I just search for tags, so this should actually give me how to use tags. So this is giving me the tags of Git. So let's search directly GitLab tags for runner. So we'll go to the official documentation. So after configuring runner, anyways we'll tag them, and once you tag them you need to invoke it using this tags. So every job will have to run in our newly created runner. So we'll use tags for for all the jobs, or else. So what I'm going to do is I'm going to take this in my pipeline, I'm going to put it at the default level and change it to Kubernetes, which is my tag that is associated with the runner. So now every job will use this runner. You can also see the jobs using this particular runner by creating the pod. So here every step of this will work. So let's see all these, like check version. Also I'm going to see build job. So in case of runner, so this runner is going to create a pod for each job, and also what container image that pod should run is already defined at the global level, and you can also override it at the job level. So it's the same thing, but instead of using shared runners here, Kubernetes pods will be used. So I'm going to uncomment everything, that is unhide everything. So Dockerize also this. So there is one issue. So this Dockerize stage, which is using the service concept of GitLab, it will not work as expected in case if you're using Kubernetes pods. So I've tried a lot of other things, but it is still not working. Then I found a different way, that is using Kaniko to actually build our job. So let's completely delete this stage and then use, so the naming convention, anyways we are going to follow the same thing, but let's remove the services concept, the script and all. So we're going to use Kaniko to build container images. So for this, in the readme.yml file I already gave some references, so you can go through these references and understand how to use Kaniko. So let me go to the first link. So this is how you use. So this is the image you can use for that particular job, and entry point should be set to empty, and you can invoke the Kaniko executor with the context, that is the current directory, and the location of the Docker file, and the destination you wanted to push the image. So this is how you can use Kaniko, and also a small snippet is also given here. So I'm going to take this snippet and help you understand how I actually created this. So let's understand. So this is the image and this is the entry point, and as a script. So basically this Kaniko, if you have gone through many of my old videos, you would have understood that Kaniko, once it builds the image, it can also push to the registry. So by default these registry credentials will not be cannot be put inside this particular container image. So that's why we need to provide it manually. So where do Kaniko expects the basically the login credentials to be stored is, so under the Kaniko .docker and config.json. So this is the JSON file that actually will have the registry and credentials to access that registry. So if you don't know how to actually create that config.json, so I have this Kubernetes example. so where we talk about pulling an image from private registry. So for this, what we need to do is we need to basically do docker login in our system, and that will generate the config.json in the .docker folder. So this will look exactly like this, that auths, the URL to the registry, and the auth token. So this auth token is the base64 encoded with username, password, combinedly base64 encoded. So what I need to do is I need to actually create this particular file with the registry information and username and password information, and I need to base64 encode it, and I have to put the value. So for this I did the same thing. So I've used URL, the escape sequences to come to this particular complete echo statement. So if you see, I have auths and the CI registry, the variable that is holding the registry location, that is, it can be a third party registry or it can be DockerHub. And auth, if you see, I have username, password, that is username and password, so combinedly base64 encoded, and the total value is echoed into this config.json. Now the Kaniko can use this config.json to authenticate and push your image to the registry. And for pushing, what I'm doing as a destination, I'm setting the username, the image name, and the tag. So what is username is your DockerHub username, and as we already discussed, so this username is already stored. So that means the CI registry user is exactly your username, and those details are also given in the readme.md file. So what exactly you need to put here? So here there is a small what do you say, the correction is needed. So the CI registry, instead even though DockerHub is the default one, you need to actually input it here. And the password, that is CI registry password, which is Docker password and Docker user as usual. And the image also, you can either set it here or else you can set it in the job level variables also. It is up to your choice. So let's do one thing. Let's actually add these variables to the project. So here I'm going to setting CI/CD, and then go to this variables, click on add variable, and as a key, as I already discussed, so we need to add couple of keys. So one is the CI registry, so this way is the value to it. So CI registry, just cut everything and paste it here. So it is HTTPS index, so properly remove all the extra spaces. So protect, uncheck it, and mask variable is not needed. So this is one thing. And CI registry image, it's up to you to either put it as the variable, or else you can also put it at the job level, because this is just an image name. No need to put it at the project level. And CI user and password, we already have it saved as username and password. So when we did Docker login in our previous scenario, so I'm going to use the same thing. So this becomes the username, and this becomes the password, which we already have. And so auth, CI registry I already set, and project directory, it is the predefined variable, so it will find the Docker file from the current location. And the destination, I'm setting it to username / image name. So username comes from the global values, and this image name comes, if you see, I already have it here. So as a tag also, I will add it here for the image tag, and this one I'll say it is CI commit SHA. So as usual, so instead of putting it in the job level, I simply put it at the global level to to show that this also will work. So here so it is giving me this error, property tag is not allowed. So maybe I can use tag name or something. So let's see why it is not allowing. Sorry, this is the default name, so not this. So it should go into the variables actually. That's the reason why it is giving the error. So tag name, it's commit SHA. So now this should work as expected, but here So instead of before testing this whether this push is successful or not, let's do one thing. Let's disable the other stages, like build job also I'm disabling it, SonarScan also I'm disabling, push to Nexus I'm disabling, so dockerize, so deploy to Kubernetes I'm deploying, I'm disabling. Now for the dockerizing, so it will just dockerize, but if you see the Docker file, it is expecting this war file and all, so I'm just going to comment this out. So this is basically a simple Docker file which does nothing other than tagging this image. So we are doing it just to see whether this Kaniko image build and image push will be successful or not. So let's save this and then so commit this particular code. So git add -a. So git push horizon master, and let's see the jobs. So Dockerizing should actually start, but this is in the pending state. So the reason why is here we are no longer using the shade runners. We are using the Kubernetes pods as the run executors. If you see, we now have one more pod running, so to execute our job. That's the reason why it took some time in order to start this particular job. Now if you see, my push is successful, and this is the commit shop, so which means everything is working properly. So now let's do one thing. Let's actually make some changes by removing all these jobs. So now scan unhiding all these jobs and deploy to Kubernetes also. So earlier this release is already available and it is running. And also let's do one thing. Let's go to pom.xml file and change this version number from 1.0 to 2.0. So we'll also see whether this 2.0 war file is available in the Nexus or not, and whether SonarScan stage is successful, and also Dockerizing and deploying to Kubernetes is successful or not. So we will check all the jobs, because we have unhided all the jobs. So let's add the changes and then commit them and then try to push it to the horizon. So this should trigger all the jobs one after the other. The first one will be checking the Maven, and then your build job will start, and after that SonarScan, then push to Nexus, then Containerize, push to DockerHub, and finally it's a deploy to Kubernetes stage. So check version job is successful. If you see here, it is returning Apache 3.8.2 as expected. Now let's see the status of other jobs. So currently your build job is running, so let's wait. And if you also see the pods, so for every job it will create a new pod. So you can also see there is one pod currently in the running state from 73 seconds. Now if you see the pod is in the termination state, so new pod will be created for our next job in the list. So again a new pod is being created. So this has to run our SonarScan stage. So let's go back to the list of jobs. So this is the SonarScan stage. So it is using this image as the executor image, that is the container image, and it also says quality gate is passed, and I can see the results. So let's go to our SonarQube and click on projects and see whether quality gate is passed or not. So this is actually passed. On the overall code, and If you also see, so the last timestamp is showing 1 minute ago, so which means, so this analysis also passed and call ticket information is passed back to the client. So let's go back to the other jobs. So now push to Nexus stage is starting, and if you see the list of pods, the earlier pods were in the termination state, and a new pod has been created for our Nexus stage. Now if you see, so the artifact is getting pushed to the Nexus repository, and it is stored with 2.0 version, and the job is successful. If I go to the repository and browse the repositories, so in the Maven hosted releases, you should be able to see 2.0, which is just pushed to this repository by one of the job. Now let's see the rest of the jobs. So the next job is Dockerize job. You can also see the list of pods. The old pods are terminated and a new one got created, and also the this particular job is very quick to finish because it is just containerizing and pushing the image. But we did a small mistake here, so we did not uncomment the Docker file which we have commented out, so which means our deployment will actually will not work, because so this is just an open JDK image. Here we did not copy our war file into the actual image and containerize it. So let's see the final job, which is deployed to Kubernetes. So this is also passed, but if I just check the list of pods, so in most cases our pet clinic project should not run as expected because we did not dockerize it properly. So our pet clinic project, it is running, but internally it will not work because we have a wrong image. So now what you can do is you can just uncomment this Docker file and run the whole pipeline again. So this time it should work as expected. So this is how you use your own runners instead of using shared runners provided by GitLab. Thank you, and I'll see you in the next one.